In this video, we'll be going over find peak elements. So a peak element is an element that's strictly greater than its neighbors. Given an integer array nums, find peak element and return its index. If the array contains multiple peaks, return the index to any of the peaks. You may imagine that the alpha indices at -1 and n is negative infinity. You must write an algorithm that runs the O of log n time. So in first example, we'll give it this array, 1, 2, 3, 1, and the peak is at 3 because 3 is greater than its neighbors 2 and 1, so we want to return its index, which is at 0, 1, and 2, so return 2. And on constraints, we can see that the neighboring numbers are not equal to each other. Let's go over the thought process. So let's first go over the brute force approach. So the brute force approach will be to perform a single iteration through the input array. For each of the index I, we can check if I is the peak by checking with its neighbors. Neighbors at I minus 1 and I plus 1. Now this approach will give us O of n time complexity. Now let's go over an approach that will take O of log n. So O of log n most likely means binary search. Now for each of the index I, if nums I is less than nums I plus 1. This means we're currently going up an upslope, so the peak must be located on the right side. So the peak must be located on the right side from I plus 1. Now if nums I is greater than nums I plus 1, this means we're currently going a downslope, so the peak must be located on the left side from I. We're doing it from I because the current index may be the peak. Now let's go over the pseudocode. So we're going to create the following variables to keep track of our left and right boundaries for our binary search. The left boundary, initially 0, and then the right boundary, initially at the end of the array, so nums.length minus 1. While left is less than right, we're going to calculate the mid index. So mid is go to left plus right minus left divided by 2. Now if nums mid is less than nums mid plus 1, this means we're currently going up an upslope, so we need to search to the right from mid plus 1. And we'll set left to mid plus 1. We're searching to the right. Else we need to search to the left, starting from the current mid index. So I'm going to set right to mid, and then we can return left, which is the peak index. Let's go over the time and space complexity. For the time complexity is O of log n, where n is the length of the input array. This is for the binary search. Our space complexity is O of 1. Let's go over the code. So we're going to create the following variables to keep track of our left and right boundaries. And then while left is less than right, we want to calculate the mid index. If nums mid is less than nums mid plus 1, this means we're currently going up an upslope. We need to search to the right, so mid plus 1. Else we want to search to the left with mid inclusive. So right is go to mid, and then we can return the peak index. Let me know if any questions in the comment section below.